discuss model questions in probability. The first question is, given that A and B are two mutually exclusive events. Mutually exclusive means A intersection B is null set, which means P of A intersection B is equal to 0. And A union B is given as sample space, which means they are exhaustive events. So P of A union B is equal to P of S. And we know that probability of sample space is 1. And P of A union B formula is P of A plus P of B minus P of A intersection B. So already P of B is given as 2 times P of A. P of A intersection B is 0. So 3 P of A is 1, implies P of A is equal to 1 by 3. Option B. Next, in a room, there are 6 couples. 6 couple means total members, 12 members will be there. Out of them, 4 are selected. So what is N of S? Out of 12, you have to select 4. Selection means combination. So N of S is 12C4. Now you have to find the probability that they may be couples. Out of 4 selected, you should get 2 couples. So 6C2. So out of 6 couples, if you select 2 couples, then you'll get 4 persons who are couples. Then what is our required probability? N of E by N of S. 6C2 is 6 into 5 by 2 into 1. 12C4 is 12, 11, 10, by 4 factorial 20. So this is 15. 2 3s, 15. 12 2s, 2 5s. 5 5 gets cancelled. 3 divided by 11 into 2 letters are taken at random from the word home. How many letters are there in total? 4 letters, out of which you have to select 2. So 4C2, which is 6. N of S is 4C2. Probability that at least one letter is vowel. So whenever the question is at least one, we do by complementary. Probability that at least one vowel is nothing but 1 minus probability that no letter selected is vowel. No letter selected is vowel. Which means the 2 letters which we are selecting should be consonants. What are the consonants we have? 2 consonants we have. So 2C2 by 4C2, which is 1 minus 1 by 6, 5 by 6. Option C. Next, 3 electric lamps are to be fitted in a room. 3 bulbs are chosen at random from 10 bulbs. So altogether we have 10 bulbs. Out of which 6 are good bulbs and the remaining 4 are bad bulbs or damaging bulbs. The chance that room is lighted. So you have to find probability that room is lighted. This can be done like this. 1 minus probability that room is not lighted. So when there will not be light in the room? When all the selected 3 bulbs are bad bulbs. So when you select all the 3 as bad bulbs, there will not be light in the room. So in how many ways we can select 3 bad bulbs from 4C3 by total N of S will be out of 10 you have to select 3, 10C3. 4C3 is 4 by 10C3 is nothing but 10 into 9 into 8 by 3 into 2 into 1. 3 times, 2 5 times. This is 120. So 1 minus 4 by 120, 1 by 30, which is 29 by 30. Option D. Next, two numbers are chosen at random from 1, 2, 3, 4, 5, 6, 7, 8 at a time. So in how many ways we can select two numbers from 8? 8C2 this, which is 28. Now probability that the smaller of the two numbers is less than 4. Probability that smaller of the two numbers is less than 4 is nothing but 1 minus probability that smaller of two numbers is greater than or equal to 4. So what are the numbers greater than or equal to 4? 4, 5, 6, 7, 8. So 1 minus 5C2 by 8C2. So you can select any two from this. 5C2 is 10, 8C2 is 28. So 18 by 28 or 9 by 14. Option C. Next, again same model. Two numbers are selected from 1 to 100. So in how many ways you can select two from that? 100C2 ways. The probability that minimum of, this is similar to the previous one, minimum of two numbers is less than 70 is nothing but 1 minus probability that minimum of two numbers is greater than or equal to 70. Greater than or equal to 70 means 71 to 100. How many numbers will be there from 71 to 100? 30. So select any two from that. So 1 minus 30C2 by 100C2. Option B. E is given wrong. 1 minus 30C2 by 100C2. Next, three students ABC are to take part in a swimming competition. The probability of A winning is 3 times the probability of C, and probability of B winning is also 3 times the probability of C. Then probability of C's winning is if there is no tie. That is you have to find P of C. See here, three students are participating in a competition means definitely one of them will win the competition, and no two persons can win the competition at same time, which means A, B, C are mutually exclusive and exhaustive events. Mutually exclusive means A and B and sorry, exhaustive means A and B and C is equal to S. So P of A and B and C is equal to P of S, which is equal to 1 probability of sample space. And the formula for P of A and B and C is P of A plus P of B plus P of C minus P of A intersection B, which is 0 because exclusive means A intersection B is null set, B intersection C null set, C intersection A null set, A intersection B intersection C null set. So remaining all probabilities become 0, so this will become 1. So P of A is 3 times P of C, P of B is also 3 times P of C plus P of C. So altogether 7 P of C is 1, so P of C is equal to 1 by 7. Option D. Next, from the set 1, 2, 3, so on up to 20, three numbers are chosen at random. In how many ways you can select 3 from 20? 20C3 ways. And the selected numbers should form arithmetic progression. Let us say the selected numbers ABC are in, let the selected numbers are ABC, which are given in AP, which means A plus C is equal to 2. 2B is even, right? So for the sum to be even, For the sum to be even, both the numbers A and C should be either even or both should be odd. Even or both should be odd. Then only you will get sum as even. From 1 to 20, there are 10 odd numbers and 10 even numbers. Now tell me what is n of p then? We have to select both even means 10C2 or plus both odd. That is also 10C2. So this is 2 times 10C2, which is 90. And n of s is 20C3. And the required probability P of E is nothing but n of E by n of s. 20C3 is 20 into 19 into 18 by 3 factorial, which is 6. 6 3 times, 3 30 times. So 3 by 38 is the answer. Option A. A class has 15 boys and 5 girls. 15 boys, 5 girls. 3 students are to be selected. So altogether 20. Out of 20, we have to select 3. So n of s is 23. And out of the 3 selected, there should be 2 boys and 1 girl. So what is n of e? In how many ways we can select 2 boys from 15C2 into 1 girl from 5C. 20C3 is 20 into 19 into 18 by 3 factorial 6, 6 3 times. 15C2 is 15 into 14 by 2 into 1 into 5, 7 times. So what will be the required probability n of e by n of s, which is 15 into 7 into 5 by 20 into 19 into 3, 3 5 times, 5 4 times. So this is nothing but 35 by 76. Option A. Next, A tosses 2 coins. A tosses 2 coins. B tosses 3 coins. Then the probability that B obtains more number of heads. A tosses 2 coins means what are the possible cases? HH, HT, TH, TT. B tosses 3 coins. So there are 8 possible cases. HHH, HHT, HTH, HTT, THH. So these are the 8 possible cases here. Now probability that B gets more number of hits means, look here. Suppose if B gets 3 heads, A may get either 0 head or 1 head or 2 heads. Suppose if B gets 2 heads, A may get either 0 or 1. If B gets 1 head, here 0. Now, when B gets 3 heads, what is the probability of getting 3 heads for B? 1 out of 8. In that case, A gets either 0 head or 1 head or 2 heads. 0 head or 1 head or 2 heads means how many possibilities? Either 0 heads means both tails, 1 head means these 2 cases, 2 heads means this. So 4 out of 4. Plus, what is the probability of getting 2 heads for B? 2 heads for B means 1, 2, 3, 3 cases out of 8. In that case, A should get either 0 head or 1 head. Either 0 head or 1 head means how many cases for A? Either 0 or 1. 3 cases out of 4. So 3 by 4. And last case. What is the probability of getting one head for B? One head for B. How many cases are there? Where you get one head? This is one. This is one. This is one. 3 cases out of 8. In that case, I should get 0 heads in for A. 0 heads for A means 1 by 4. So if you simplify this, your answer will be 1 by 2. After simplification, you get answer as 1 by 2. Option C. If a coin is tossed 4 times, so if a coin is tossed 4 times, n of s will be 2 power 4, 16. Then the probability that heads exceed tail number. Heads exceed tail number means when you get 3 heads, you should get 1 tail. 2 heads, 2 tails means it's not the required case for us. So 3 heads, 1 tail in 3 heads, 1 tail is one possibility. 2 heads, 2 tails is not correct. So this is the only case. Here we can get 4 factorial by 3 factorial cases, that is 4 cases. So n of e is 4. Then what will be p of e? 4 by 16, which is 1 by 4. Option B. So let's exceed tail number. Sorry, one more case is left over. 4 heads, 4 heads, 0 tails is also possible. This is only one case, so altogether 5 out of 16. Option C. Two symmetrical dice are thrown. N of s is 6 square, which is 36. The probability of getting sum of 6 points. When two dice are thrown, what are the possible cases where you get sum 6? I may get 1 5 or 5 1, 2 4, 4 2, or 3 3. So favorable cases are 5 out of 36. So required probability is 5 by 36. Option B. A and B throw with 3 dice. If A throws sum of 16 points, then what is the probability of B throwing a higher sum? See, what is the higher sum which is more than 16 means? Sum can be either 17 or 18. Then 3 dice are thrown, what are the possibilities of getting sum 17 means? 6, 5, 6. This is one possible case where you get 3 factorial by 2 factorial 3 cases for sum 17. For sum 18, only 666, only one case here. Minimal possibilities of sum 18, so sum 17, 665. So n of e will be 4, n of s will be 6 cube, 216. So required probability p of e will be 4 by 216, which means 1 by 54, option C. Next, on a symmetrical die, the numbers 1, minus 1, 2, minus 2, 3, and 0 are marked on at 6 places. If such a die is thrown 3 times, so what will be n of s when a die is thrown 3 times? 6 cube, which is 216. Then the probability that sum of points on them is 6. What are the possible cases where you get sum as 6 means? 1, 2, 3, 3 factorial cases, 6 cases. Next, 3, 3, 0 is also possible. Here, 3 factorial by 2 factorial, 3 cases you will get. Any more cases where you got sum as 6 when 3 dice are thrown? 2, 2, 2. This is one case. So altogether 10 cases, 10 parallel cases out of 216. So P of E is 10 by 216, which is 5 by 108. Option C. Next, a die is thrown 4 times. So N of S will be 6 power 4. The probability that 3 and 6 will turn up exactly 2 times. That is 3 you should get 2 times, 6 you should get 2 times. This can happen in 4 factorial by 2 factorial, 2 factorial, which is 24 by 4, 6. So N of E is 6. P of E is 6 by 6 power 4, which is 1 by 6 cube, 1 by 216, or 1 by 6 cube, option B. Next, 2 dice are thrown. So what will be the N of S? 6 square. The probability of getting a doublet such that sum is greater than 9. Getting doublet means getting same number on both the dice, and it should be greater than 9 means 10 is one possible case, 12 is one possible case. So N of E is 2. So P of E is 2 by 36, which is 1 by 18, option B. Next, A and B are two events such that P of A is given, P of A and B is given, P of B is P. Find the value of each if A is subset of B. If A is subset of B, then A intersection B will be, if A is subset of B, then A intersection B will be A. Then P of A intersection B will be P of A. P of A intersection B is nothing but P of A plus P of B minus P of A union B is equal to P of A, which means P of A 1 by 4 plus P minus 1 by 3 is equal to 1 by 4. From this, P is equal to 1 by 3, option D. A and B are two events such that P of A intersection B is given, P of B minus A is given. And what is P? P of B minus A is given as 8 by 25. Formula for P of B minus A is P of B minus P of A intersection B, which is 8 by 25. So P of B is equal to 8 by 25 plus P of A intersection B is 3 by 25, which is 11 by 25, option A. Next, two events A and B have the probabilities 0.25 and 0.5 respectively. The probability that both A and B occur simultaneously means at same time, which is P of A intersection B. Now the question is, find the probability that neither A nor B occurs. Neither A nor B occurs means A should not occur and B should not occur. That is P of A bar intersection B bar is our required probability, which is nothing but P of A union B whole bar by using De Morgan's law, which is 1 minus P of A union B. This is 1 minus P of A union B formula is P of A plus P of B minus P of A intersection B. All the values are given. Substitute all the values and simplify, you will get answer as 0.39. Option A. Next, A and B, A, B, C are mutually exclusive and exhaustive, which means intersections are null sets. A intersection B null set, B intersection C null set, C intersection A null set, A intersection B intersection is a null set. Exhaustive means union is equal to sample space, which means P of A union B union C is equal to P of S, which is 1. And P of A union B union C is nothing but P of A plus P of B plus P of C. All the other properties become zeros. And P of A, P of B is 3 by 2 times P of A. P of C is 1 by 2 into P of B, and P of B is 3 by 2 into P of A. So P of C is 3/4 P of A. So this is 3/4 of P of A. Simplify this. If you take LCM 4 P of A plus 6, 10 plus 3, 13 by 4 P of A is equal to 1. This is 4 by 13. From this you will get P of A as 4 by 13. And the question is finding P of A union C, which is P of A plus P of C, intersection is 0. P of A is 4 by 13. P of C will be 3/4 into 4 by 13, 3 by 13. Because P of C is 3 by 4 times P of A. So 3 by 4 into 4 by 13, 3 by 13. So final answer is 7 by 13. Option C. Option C is correct. Next, A and B are seeking admission into IIT. If probability for A to be selected is 0.5 and that of both to be selected means A and B intersection is 0.3, then at most probability of B is dash. That is maximum value of probability is dash. What is the formula for P of A union B? P of A plus P of B minus P of A intersection B. So this is 0.5 plus P of B minus 0.3. So this is 0.2 plus P of B. Now we know that probability of any event maximum value is 1. So P of A union B is less than or equal to 1. For this to be less than or equal to 1, the maximum P of B can be 0.8. Because if P of B is more than 0.8, then it will be more than 1, which is impossible. So at most what P of B can have is 0.8, option B. There are three events A, B, C, one of which and only one can happen. What does it mean? Both events cannot occur at same time, which means mutually exclusive. All the events are mutually exclusive. And definitely one of those events will happen surely means they are exhaustive events, which means A union B union C is equal to S. So P of A union B union C is equal to P of S, which is 1. Next, odds against A is given. As per the definition, odds against A means P of A bar is to P of A, which is 6. Odds are 7 to 3 against A, 7 is to 3. And 64 against B. So P of B bar is to P of B is 6 is to 4. Now you have to find odds against C means P of C bar is to P of C is equal to how much? Now what is P of A and B and C? Just P of A plus P of B plus P of C, that's all. What is P of A from this? 3 by 10. P of B from this 4 by 10. From this P of B is 4 by 10 plus P of C. So from this P of C is nothing but 1 minus 7 by 10, which is 3 by 10. If P of C is 3 by 10, P of C bar will be 7 by 10. Then what is the required ratio? 7:3. Option C. Next, if A and B are two events such that P of A is 3 by 8, P of B is 5 by 8, P of A union B is 3 by 4, then what is the conditional probability P of B by A? P of B by A is nothing but P of A intersection B by P of A. So first you have to find P of A intersection B. For that, what is P of A and B formula? P of A plus P of B minus P of A intersection B, which is given as 3 by 4. From this, P of A intersection B is equal to 3 by 8 plus 5 by 8 is 8 by 8, 1. 1 minus 3 by 4, 1 by 4. So this is 1 by 4 by 3 by 8, which is 2 by 3. Option 2 by 3 is the correct answer. Let us check once. P 3 by 8 plus 5 by 8 minus P of A intersection B is 3 by 4. So P of A intersection B is 1 by 4. P of B by A is P of A intersection by P of A. So 1 by 4 divided by 3 by 8. 1 by 4 into 8 by 3. 2 by 3 is the correct answer. Next question. If A and B are two events such that P of A union B is 5 by 6, P of A intersection B is 1 by 3, P of A 2 by 3. Then which type of events A and B are? What is the formula for P of A union B? P of A plus P of B minus P of A intersection B. So 5 by 6 is equal to 2 by 3 minus 1 by 3. From this, P of B is equal to 5 by 6 minus 1 by 3, which is 1 by 2. So what is P of A into P of B? 2 by 3 into 1 by 2, which is 1 by 3. What is P of A intersection B? That is also 1 by 3, which means P of A intersection B is equal to P of A into P of B again. This is the condition for two events to be independent. So if P of A intersection B is equal to P of A into P of B, then the events are independent. Option B. Next, A and B are two independent events given. If A and B are two independent events, P of A intersection B is P of A into P of B. P of A union B bar is given as 0.8. From this, P of A plus P of B bar minus P of A intersection B bar is 0.8. If A and B are independent, we know that A and B bar are also independent. If A and B are independent, A and B bar are also independent, and hence P of A intersection B bar is nothing but P of A into P of B bar. So from this P of A, if P of B is 2 by 7, P of B bar will be 5 by 7 minus P of A into again P of B bar 5 by 7 is equal to 0.8. So take P of A common, then you get 1 minus 5 by 7 is equal to 0.8 means 8 by 10, which is 4 by 5 minus 5 by 7. So P of A into 2 by 7 is equal to, take LCM 35, 28 minus 25, 3. From that, what will be P of A? 7 5 times. So you get 3 by 10, which is 0.3. Option C. Next, a committee of 6 persons is to be formed from a group of 7 gents and 4 ladies. What is the chance that committee consists of ladies majority? So ladies should be in majority. I have to select 6 persons. So I can select 4 ladies, 0 gents, 3 ladies, altogether 6. Sorry. So 4 ladies, 2 gents. If I select 3 ladies, then 3 gents, but majority should be ladies means this is the only possibility. So what is N of E? 7C2 into 4C4. 7C2 is 21, 4C4 is 1. And what will be N of S? Out of 11, you have to select 6, 11C6. So what is P of E? N of E by 11C6 means 11C5. 11C6 is same as 11C5. 11 into 10 into 9 into 8 into 7 by 5 factorial, which is 120. Simplify this. 7 3 times, 10 12 times, 3 3 times, 3 4 times, 4 2 times. So 1 by 22. Option B. Next, the probability of drawing 4 white and 2 black balls in 2 drawings in succession from a bag containing 1 red, 4 black, 6 white balls. If the drawing is without replacement, the probability of drawing 4 white from 6 white, we have to select 4 white and 2 black balls in 2 drawings, not at a time, in succession from a bag containing 1 red, 4 black, and 6 white. So, what is the required probability means? First, what is the probability of selecting 4 white from 6 white? 6C4 by 11C4 into, and I should select 2 black balls. 4C2, 4 from 4 black ball, 2 black balls will be selected 4C2. By total number will be now, already I have selected 4 white. So out of 11, already I have selected means only 7 are left out. So from that I have to select 2. So 6C4 by 11C4 into 4C2 by 7C2. So in second option, 6 should be there here. Option B. Next, 7 coupons are numbered 1 to 7. Now 4 are drawn one by one with replacement. So 4 coupons are not drawn at a time, they are drawn one by one with replacement. The probability that the least number appearing on any selected coupon is greater than or equal to 5 means I should get either 5 or 6 or 7. So what is the probability? 3 out of 7. That should be repeated 4 times. 3 by 7 into 3 by 7 into 3 by 7 into 3 by 7, which is 3 by 7 whole power 4. Option A. Next, if A and B are two independent events such that P of A given, P of B given, you have to find P of B by A union B. This is nothing but P of B intersection A union B by P of A union B. B intersection A union B is nothing but B by P of A union B is P of A plus P of B minus P of A intersection B is nothing but P of A into P of B because events are given as independent. Now substitute all the values given. So 3 by 4 by 1 by 3 plus 3 by 4 minus 1 by 3 into 3 by 4 is 1 by 4. So this is nothing but 3 by 4 divided by 1 by 3 plus 1 by 2, 5 by 6. So 3 by 4 into 6 by 5, 18 by 20 or 9 by 10. Option C.